Todd Badine. I'm the Field Application Engineer for North America. Today, I will be running you through a brief overview of grade metrics. I will start with how the machine operator would use the system to grade with a dozer. Currently, we have two different ways the operator can set the machine up to get cut or fill information inside of the dozer cab. The first would be creating a job inside of grade metrics. This option will be used if the project has been designed by an engineer and the job has a set of blueprints or plans. These plans will be based off a known horizontal and vertical grid that the machine will have to match. I have an example of a job loaded and shown here. Notice all of the grade breaks shown on the side of the road in the cross-section view. This is showing you an image of a dozer blade as you're looking at it from the cab. The red is the surface that we're wanting to cut or fill to. If I zoom in on the plan view and start to approach the curb, you will notice that both the plan and the cross-section views change to reflect the location of the machine. Along with cross-section view, the operator can use the light bars located here on the left and right side of the screen to adjust the blade and maintain grade. Watch when I go past the back of curb. The light bar will now indicate that I have a foot plus of fill. Now, when I back into the road prism, it returns to grade. Grade metrics is additional views that will help the operator maintain grade. These can be found by using the icon in the upper right hand corner. Some of my favorites to use is the plan, section, and profile view. If pushing towards a fill slope, the profile image here in the lower right will show the operator where to stop before overfilling the slope. Plan and section will add a large, colored cut fill area that is easy to see in your peripheral vision. It will also display both current crossfall of the blade in a percent value and also show the crossfall design surface directly underneath the blade. The profile and section view is useful when you create your own designs and don't have to worry about any of these kind of grade breaks. For now, I will keep directly underneath the blade. The profile and section view is useful when you create your own designs and don't have to worry about any of these kind of grade breaks. For now, I will keep it on dual cut and fill. If the operator would want additional information like elevation or design elevation, it can be found in the information summary. Simply tap on the icon here to open it. It will display a multitude of different information that can be customized to show more or less information. It is important to note that the info summary is obtaining that information from a specific part of the machine, shown by this green triangle in the cross-section view. It is now set to blade left. If we wanted to know what the elevation is on the right side of the blade, you just have to click and hold on the blade to change it. Now the summary data will be referenced from the right side of the blade. To close the summary, click on the same icon that opened it. When models are created for a job like this, it is generally built to a finished surface. This would be top of asphalt, concrete, or gravel depending on the job and the materials. The operator would have to offset the thickness of the material to get to subgrade. We can do this in a few different ways. Below the left light bar, you will see the up and down arrows. If we click on the down arrow, you'll notice that the offset numbers change by 1/10 at a time. The upper number here is showing you how much cut or fill you have, and the lower is our offset. The cross-section view also has a new line going across it that represents our new grade. If we have a large offset number or a number not divisible by 1/10, we can manually enter the offset by clicking and holding on the light bar. You can manually type in the offset here. A negative number means that you'll go lower or cut more. Step is the amount each vertical offset button will add or subtract when pushed. If the job has more than one vertical offset, for instance, one for subgrade and one for top of rock or finish course, you can save the current offset by clicking and holding the preset, making it easier to switch in the future. Guidance lines will provide us with station and offset from a selected line. This will work with any of the CAD lines that you bring in under the linework file. From the main screen views, click and hold on the line that you would like to get the stationing and offset from. A new menu will appear. Select the Use Guideline checkbox and select OK. We will now see stationing and offset while I navigate along this chosen line. Now that we know how to use grade metrics with a job that's already been loaded, I will show you how to create a job and describe the files needed to start. The icon at the top left is how we access the menu. The very first option is New Job. First, we name the job and click Next. The first file it is asking for is a localization. The localization file is gathered by using a rover and site metrics. The job or project will have known control points that are established by a surveyor in the early phases of the design process. Sometimes you will find the northing, easting, and elevation of the control points on the plans, or you will have to request them from the project owner or general. When you get the control information, you will have to shoot each point using a rover. All this does is equate a specific lat long and height to a known northing, easting, and elevation. Once you complete this, you can save it to a thumb drive and bring it into Grade Metrics. We also have the capability to bring in a calibration file from Trimble Construction or export the point data needed from TopCon for customers with mixed fleets. The second file is line work. This is the lines that you see in the plan views and are obtained from project engineers or model builder. For line work files, we accept DXF or DWG. I now have the localization and the line work files selected. When I select next, it will ask for the third and final file, a surface file that contains the project's finished grade attributes, elevated to the correct elevation to form a three-dimensional surface that Grade Metrics can read. These can be built using the CAD data or line work file from the engineer and numerous different CAD packages, where nowadays it is inexpensive to get built by a model builder. We accept most file types like DXF, DWG, XML, DTM, among others. Once you've selected the surface file, click Next and make sure the units are set correctly. We select Next one more time to see the localization file in text format. If bringing in a Trimble cal file, you will see the calibrations residuals here, showing how accurate the localization will be. Once satisfied, finish the job. Again, the above process is used for projects that have been engineered and have a CAD file or set of plans. There are times when the customer will not be on an engineered site, or that site will need a redesign done. We have included a few tools that will still allow the machine owner to use Grade Metrics in this case. You do not need to localize the site or have any files for this to work. All you would need is RTK corrections from a base or internet corrections from a BRS network. Setting a base on an unknown point and making it broadcast is easily done within Site Metrics. From the main screens, go to the menu and select Field Design. We have 4 different types of field designs that we can use. Notice that every type of field design can be named and is automatically saved for future use, making it easier to switch back and forth between saved designs. Flat Pad will create a pad at the same elevation on all sides of the machines forever. To use this, first drive the machine to a known grade or stake. If the stake has a cut or fill to the desired grade, we can fix that later in the vertical offset menu. Give the pad an appropriate name and select Record in the lower left corner. Once it is recorded the elevation, select Finish. You will now see the color of the surface has changed to green and you now have a flat pad. We can still see the job's design surface in red, but if I drive over to a portion sticking above the new pad, it will still give me the cut or fill to the pad and not the design surface. This will make it easier when doing redesigns in the field. If the stake that you benched on at the beginning had a cut or fill, you can easily add it by clicking and holding on the light bar and typing it in the offset. The second design is Hold Slope. This is used in conjunction with guidance lines to allow a particular percentage off a line based off the position of the blade and the guidance line selected. To select a guidance line, tap on the line you would like to use and check mark the Use Guideline box and press OK. Now position the dozer with the desired blade cross slope. The emulator does not allow me to angle the blade, so I will only be able to show you using a 0% crossfall. If I go back to the field design and hold slope, I can press Record and now Finish. You will now see a new surface color holding that 0% crossfall at the guidance line's elevation. This would be useful for road slope redesigns or if a contractor needed a place to get rid of some extra material. The third option in field design is Slope Pad. This will do anything a dual plane laser can do, useful for parking lots, tie-ins, and 2 known areas. To start, position the machine on a known grade or stake and facing the direction of the proposed mainfall slope. Now press Record. And now Next. You would now drive the dozer in the direction of the mainfall heading, and you can also place the blade down to establish mainfall % between the 2 points, or you can type it in manually if needed. I cannot move the dozer in the emulator in this menu, so I will just type in the bearing, distance, and slope, and select Record. And Next. Now it's asking me for a desired cross slope. I will give this positive 5% so we can see it when it's finished. When I track ahead, you'll see the existing surface fade because of the increased slope while moving forward, and we now have a 5% crossfall. The last field design we have is ramp. It is very similar to slope pad, but it will give you the option for a second grade break or 2 sloped pads based off the line that you record. Think of a B-ditch or a crowned road. Just like slope pad, I will start with a known grade, elevation, or stake, and start with the machine facing the proposed main fall direction and press record. And next. You would again drive in the direction of the main fall to establish the bearing and either use the blade to create the main fall slope or enter it in manually and press record. Since I cannot move the machine in this menu, I will just type in the bearing, distance, and slope and select next. Now it is wanting me to build a cross-section template. Side of center is used to tell what side of the center line I want to project my new lane. I will give this one a 12-foot width and a -2% fall. I'll do the same for the right. You could also add additional lanes to the template if needing, giving the operator the ability to build a complex model with ease. Once satisfied with the template created, just push next and then finish. You can now see the crowned road that we have created. Inside of the Topo submenu, the dozer has the capability to manually record single points and also record points based off of predetermined distance or time automatically. You can also save any points recorded to a certain file. For example, you could have a file for utilities, existing topo, or manholes. You can also add a code description to the point by using our default selection or add your own. In the main view of topo, you would just have to choose to shoot a single shot for a manually recorded point, or you can start the auto topo using the established values in the setup menu. There's a second page to our menu. This is used to change the radio channel or adding credentials to a VRS network. This is also where the install wizard is located. Equipment setup will guide you through the install process. First, name the machine and pick the units you are using to measure the machine with. The next menu is asking you for the dimensions from the center of the base of the cutting edge to the center of the primary antenna. This can easily be achieved using a rover. The chassis is for scaling the image of the dozer in grade metrics. The blade measurements are also very easy to measure. The next menu is used to tell where the sensor is located and which way they are facing. On the dozer, we have one sensor located on the cab and one on the blade. The sensors are shaped like an arrow, so it is easy to identify the facing. The writing on the top of them will tell you the position. The final screen shows us the measurements we inputted. Verify they are correct and finish to save. The final portion of the install, we will be calibrating the sensors. The wizard does a great job walking us through it. Park on a hard, flat surface and then mark the blade. Then press record. And next. Notice how the image has changed? We flip the dozer around and park the blade on the painted line and press calibrate. And finish to save.